Okay, hello everybody. Today is gonna be lecture number 2 in the statics course, and we are going to start from the last thing we did stop at the last lecture, and it was the units of measurements and the systems of units. So basically, there are two systems of units: the international system of units, which is the SI units, and known as the metric system, or the US customary system, or known as the English system. In this table you can see the difference between each of the two systems in terms of the basic quantities, which are the length, mass, and time. Also, there's the force as well here, but in fact the force is a derived quantity, and this is not basic quantity. We will come talk about that in just a second. So you can see that for the length, it's foot in the English versus meters in the SI. For the mass, slug versus kilogram. And for the time, it's the same in both systems of units. So what do I mean by basic versus derived quantities? The to simply explain this, you have to know that the derived quantities are derived from the basic quantity. So if you consider the area, it's just to multiplying the length 2 times, you'll get the area. 3 times, you will get the volume. If you consider the density, it's gonna be mass divided by the volume. It's gonna be composed of the basic quantities. So the derived quantities are those derived from the basic quantities, and the basic quantities are not derived from anything. They are basic. Another thing we are going to talk about, which is the prefixes. And when we talk about the prefixes, it's a way to actually describe the magnitude or the order of magnitude of the basic quantity. So for instance, if the basic quantity represents the 1, which is 10 to the power 0, then if you talk about 10 to the power 1, which is the 10, it's deca, then you have hecto, kilo, mega, giga. Yeah, I think you know, you're very familiar with those three, which is like, if you let's talk about uh, Pascal, for instance. We know that kilopascal, you have megapascal, you have gigapascal as well. Let's talk about the other way of the prefixes when you describe it as a fraction of that one. So when you have 0.1, it's deci, then 0.01, it's centi, and then and so on. So you know that, for instance, if we're talking about centimeter, it's 0.01 meters. So if you're talking about millimeter, it's 0.001 meter, and so on. So it's just pay attention to the prefixes, and I think we're gonna just basically it's very easy to understand them and memorize them. Especially those are easy ones, and here you're gonna be dealing with those three very commonly used. So the conversion of the units, it's very important when you deal with any mathematical equation or any mathematical operation, either addition, subtraction, multiplication, or division. You have to have a consistent system of units. So you cannot perform mathematical operations on two different systems of units. So you cannot, for instance, add 1 meter to 1 foot. You'll have to have 1 meter plus 0.3048, which is the conversion between 1 foot and 1 meter. And this is going to be 1.2348 meters. So this is when you have a consistent system of units. So in order to have this consistent system of units, you'll need to have to know the conversion factors. And these are the conversion factors, for instance, for the basic quantities. Uh, and you will have to memorize that. So each time the simple approach to do the conversion, is when you memorize that, each time you want to get rid of a certain system of unit, this system of unit has to be in the numerator. So let's solve this example, and I am going to start with the always start with the first number that you are concerned with converting, which is the 175. So the question needs to convert 175 pound per cubic foot to kilonewton per meter. So when you start with this number, then you need three, or let's see, we need two conversions, one for the newton and the pound, which is this guy here, and one for the kilonewton and the newton. That's actually for the force. So these are two convergence for the force. And then we also need one convergence between the foot and the meter, which is this guy here. So we know that one pound is equal to 4.448 Newton. So this is how you come up with this number. And since you want to get rid of the pound, this 1 pound has to be in the denominator. And then you cancel this out. Here you want to cancel the Newton out. Here you want to cancel the meter. Oh, I'm sorry. Here you want to cancel the foot out. But don't forget that this is a cubed. So when you have this complete and ready, you will get this number, which is the answer. So simply you will need to know the conversion factors, which are these guys here. Some of them are easy to figure out, which is between millimeter and meter, for instance, or between hour and second. This is a very simple one. Others you need to memorize, such as this one or this one here. You need to memorize, or this one here, which is the same. Okay. So if you pay attention to this, which is like it's very interesting. Like let's talk about this just for a second. So if you pay attention to this, we had the foot in the upper part of the fraction, and then you have this in the lower part, but that's because here we want to get rid of the foot. When we wanted to get rid of the meter, look, we had the meter here and here, so that we can keep the foot and cancel it. So it's just a matter of rearranging the fraction in order to get your answer. Important notes to pay attention to also when you get any numerical equations that you are solving for. You have to have a numerical accuracy. What I mean by this is not just simply round to the nearest integer like 1.75. It's not simply, you cannot say this is equal to. It might be insignificant to say it equals to, but it is not actually the common or the best accuracy. I would suggest having at least two significant digits, which is like 172. So if you have 1.7534, it's okay to say 1.75. But if you keep two significant digits, it's the best practice. Again, dimensional homogeneity. Do not use different systems. Do not use different systems of units. So this is a mistake. Be consistent. Use consistent systems. So this actually is the second lecture, and we will starting from the next lecture, we're gonna start in chapter 2, which is the force vectors, and from there we will start dealing with some mathematics and some problem solving issues. Thank you for watching. Please, if you are not a subscriber to this channel, hit the subscribe button and to to get every new and recent videos that we have and expand your knowledge in structural engineering. And if you also come back and look for a specific content that you don't find, please leave a comment so that we are aware of what exactly you need to know or learn about, and we can help with this. Thank you very much. See you later.